All right. So if there was ever a lesson you need to have your thinking cap on for, it's this one. Because like I said, it's a little bit of a puzzle. Because in every question today, you have to look for either a side or an angle, but you don't have enough information to find it right off the bat. So what we have to do is we have to use the other triangle that's there, use the information in that triangle to help us find what we're looking for. And that will make sense once we do the first example here. So in this lesson, we will come across diagrams that contain two right triangles. Remember, we can only use SOHCAHTOA in right triangles. Right triangles are triangles that contain what? A 90-degree angle, or that little square, okay? So we're going to use sine, cosine, tan, and the Pythagorean theorem. You learned the Pythagorean theorem in elementary school. That's this guy here, a squared plus b squared equals c squared. So we may, it's frozen, sorry, you're right. We may have to refresh our memories on that guy a little bit. Okay. I'll give you a second to copy that down. Before we start with this first example here, where we want to figure out the length of CD. So copy that diagram down. Make sure you have all the letters in the right spot, all the numbers in the right spot, and we'll go ahead in about 20 seconds. Okay, people are still copying, so I'll just give you a little bit more time. Okay. So if we look at this diagram here, it says we want to find the length of CD. So let's first locate CD. So that is, of course, this side right here, from C to D. That's our X. He's what we're looking for, that length. Here's the thing. That length, okay, that X, he's a side in that triangle, right? He's a side of that triangle. We always have to know a minimum of two things to be able to find something. So what I mean by that is in this triangle here, okay, I want to find X, but the only thing I know in this triangle is that that angle is 26. I only know one thing. That's not enough. You have to know at least two things to be able to find something else. So we cannot find X right now because we don't know enough in that triangle that I've outlined. We only know the 26. It's not enough. But what we can do now is we can look at that other triangle, the one that I haven't outlined that has the 47 and the 4.2. Because this triangle over here, so I'm just going to back up now. This triangle over here, he does have two elements. We know the 47 and we know the 4.2. So that means in that triangle that I've outlined, because I know two things, I can find anything I want. Okay, so I'm going to decide what should I use the 47 and 4.2 for? What should I use those guys to find that would help me in the other triangle? Any guesses? The second number? Yeah. What do you mean? Yeah, like we're going to find a second value. We're going to use this and this to find another number that will help us out in this triangle. So what would I find then? Blessing? The hypotenuse, right. So this, oh, whoops. Go away. Back spacing, back. So this length right here is the hypotenuse, and it's a shared side. Meaning if I find the length of this yellow line here, I can use it in both triangles. Okay, so I'm going to find the length of BD right now. The hypotenuse in the middle there, that yellow line. So I'm going to use the 47 as my eyeball. Now, I'm looking for the hypotenuse, and then I'm given the opposite side. That 4.2 is opposite of 47. So I'm given opposite, I'm looking for hypotenuse, opposite hypotenuse, OH, SOHCAHTOA, it would be sine. So it's going to be sine of the angle you're given equals opposite over hypotenuse. So opposite's my 4.2 over my hypotenuse. And I'll use the letter H here for hypotenuse because X, I can't use X because X is for the other side I'm looking for. We're not looking for X yet. So now I want to solve for my hypotenuse. When the number you're looking for is on the bottom, that's where you do that flip-flop. So the hypotenuse, that H, can come out on the left, and then you send that sine of 47 underneath the 4.2. So they literally just did an old switcheroo. So now you take your calculators, you do not press shift or second because you're not looking for an angle, you're looking for a side. So 4.2 divided by the sine of 47 rounded to 1 decimal place gets you 5.7 centimeters. So I just found out that my hypotenuse is 5.7. So I write it in so I don't forget about it. So now we can return to the other triangle. We're going to return to this triangle here because my ultimate goal is to find X. And now in that triangle, do I know two things now? I do. I know the 26 and now I know the 5.7. So whenever you know two things, you can find the third. So if I'm looking for X, okay, in this triangle, I'm given that this is 26, so that's my eyeball. Okay, I know the hypotenuse. Okay, so the 5.7 is my hypotenuse. Now, what side is X according to my angle of 26? Is it opposite or adjacent? Adjacent, it's right beside it. So according to that 26 angle, I know the hypotenuse and I'm looking for adjacent. Adjacent, hypotenuse, AH, which one is that? That's right, SOHCAHTOA. Which one is AH? Cos. Okay, so now we're doing the work here to actually find CD, what I'm looking for. So it's going to be cos of the angle we know, 26. Now it's adjacent on top. So the adjacent side is my X side. And then on the bottom's the hypotenuse, which we found to be 5.7. So now when the X is on top, to isolate X, we have to get rid of that 5.7 on the bottom. So I do so by multiplying each side by 5.7. So on your calculator, you go cos of 26 equals, you'll get a decimal and then multiply that answer by 5.7. You're not pressing shift or anything, and you should get the answer of 5.1. And sorry, I'm French, so I always use commas for my decimals. Sorry if that's been confusing you. 5.1, and my unit is centimeters. So you see what I mean? We kind of had to solve a problem. We couldn't find what we were looking for right off the bat. So we had to use the other information to help us, okay? Okay, next one's very similar. So I'll give you 30 seconds to copy this image down. Did I go too fast or you got that down? Okay. Example 2, determine the length of XY. So this is our unknown right there, that side, that's my X. And then those 3 red numbers, those are the numbers you're given. So this example is pretty similar to the first one, okay? So in this question, I am looking for X, and X is a part of that right triangle. FYI, if it's a right angle on this side of the line, it will also be a right angle on the other side. So there's your right triangle. The only thing I know in that triangle is the 22. With one piece of information, I cannot do anything. So I cannot find the X right now. So now we look at the other triangle, and in the other triangle, I have 2 pieces of information. I have the 8.4 and the 20. That means I can find whatever I want. So I'm not just going to find anything. I'm going to find something specific that will help me in the other triangle. So just like the other one, the other question, I'd recommend finding that shared side because I can use it in the other triangle as well. So if I'm finding that side right there, so that's our first step, we're going to find the length of YW from Y to W. This is what I'm looking for now. So in this triangle on the right, this guy here, the angle you're given is 20, so that's your eyeball. Now, which one am I going to use? Sine, cos, or tan? I'm looking for this guy, and I've been given that guy. Yes, I think I heard Hayden say it. Okay, so I'm looking for the side that's opposite of the 20, and this is the hypotenuse because it's opposite of the right angle. O and H is sine. I know it's spelled sin, S-I-N, but in math it's actually sine, okay? So it's going to be the sine of the angle you know, 20, and then it's opposite over hypotenuse. So opposite is our unknown. So don't write X because X has been reserved for that guy. So use another variable, or you can just actually call it YW. It's the side YW. It doesn't matter how you indicate it. Just indicate it with something that's your unknown. And then it's going to be divided by your hypotenuse, which is 8.4. Now, I have to multiply each side by 8.4 to cancel those out and make that YW isolated. But then I also have to multiply this side by 8.4 as well. So on your calculator, you just go sine of 20, you figure out what that decimal is, and then you multiply it by 8.4. No shift, no sign here. And you should find that the length of the side YW, that shared side, is 2.9. Okay, so I'm going to go into my triangle now and actually write in that this is 2.9. So now, what, Stacy, what's wrong? You don't get it? One sec. Okay. So now I can go back to the other side of the triangle, because in this side of the triangle, now I know 2 things. I know that degree of 22, and I know that this shared side here is that 29. So I know two things now on the left as well. I want to find x. So I always take the angle I'm given, and that's my eyeball. So according to that 22, I'm looking for the hypotenuse, and I'm given the adjacent. Adjacent, hypotenuse, AH, that's cos. Okay, so I'll do that over here. So this is where I'm finding my x or my yx, whatever you want to call it. So I said it was cos. It would be cos of 22, and cos is adjacent on top, so the adjacent's that 2.9, hypotenuse on the bottom, that's my x. Yeah. I'm sorry, say that again. We always do the eyeball. So in this question over here, this is the angle I'm given, so that's my eyeball. According to my eyeball, I'm looking for the side right beside it. That's the adjacent then. And then I'm looking for this guy, which has to be the hypotenuse, because it's the one that's opposite the right angle. Okay. Okay, so now the x is on the bottom. When the x is on the bottom, we do the flip-flop. So it'll be x equals 2.9 divided by the cos of 22. So now you have a division to do on your calculator. 2.9 divided by cos of 22 should equal 3.1 centimeters. So our first step was finding our missing piece, and then our second step was actually finding the answer we want. If you can't get 3.1, let me know. So there's two examples of finding a missing side. Okay. Now we're going to do two examples where we find a missing angle. All right. So any questions before I move on? Okay. Copy this down. Example 3, determine the size of angle X, Y, Z to the nearest degree. So copy that down and then we'll talk about what we're looking for here. So in this diagram here, again, you have your two triangles. You have your one on your left, and this is the right angle there, and you have the little one on the right. We're not given any angles here, sides only. And I want you to find angle XYZ. Okay, so when I say angle XYZ, we have to actually really pay attention to those three letters I give you, because they will dictate what angle you're finding. So when I say angle XYZ, this is what I mean. You're going to start at the first letter, which is X, right? And then you're going to travel to the next letter, which is Y. And then you're going to travel to the next letter, which is Z. I just traveled between those three letters. You see what I mean? I went from X to Y to Z, and the angle that's formed is what I'm looking for. Okay, so here I'm actually looking for the whole angle in the big entire triangle. Okay, so what that means is I have to find the angle in the left triangle. I have to find this angle in the other triangle and add them together. You see what I mean? Because I have two separate triangles, so I find that angle in each of them and then add them together and I'd get the whole big guy. Okay, so you always look for the triangle that you know more in. In the triangle on the left, I only know the 17, not going to help me. But in the triangle on the right, I know two pieces of information, the 8 and the 10, right? If you know two pieces of information, you can always find a third, whatever you want. So I would recommend using 8 and 10 to find that little angle number 2. Does that make sense? Okay. So My first step is going to be find angle. Okay, so again, if I'm naming this angle right here, that's the angle formed by those three letters, which is V, Y, Z. I'm only finding half right now. So I'm finding angle V, Y, Z. Okay. Okay, so in that angle there, the two sides that I'm given, if this angle's my eyeball, I'm given the opposite side and I'm given the hypotenuse. Opposite hypotenuse, OH sine. So it's the sine of the angle you're looking for. Okay. So the angle I'm looking for is VYZ. Is going to be the opposite side divided by the hypotenuse side. So because you're looking for an angle, you will write shift or press shift or second on your calculator. So my calculator and most of yours you have to go the division first. So 8 divided by 10 equals, and then go shift sign. Some advanced calculators, you can just press shift sign and then brackets will pop open. You put in the 8 divided by 10 equals. If you did it right, you should get 53. Okay. I'm just going to clean this up a little bit and write that in. Okay, so we know now that this angle number 2, that little sliver is 53 degrees. Okay, here's the problem though. We now have to find the other side of that angle, that little number 1. But that little angle number 1 is in that left triangle, and we still only know one thing. We still only know the 17 over there. We still have to do something yet again to help us. So, okay, I got hands up. Hayden, what do you think? Yes, we have to find this shared side. Okay? How? Yeah. Okay. So the fact that we have that 53, that will help us. You actually have two options here, okay? Because in this triangle here, you actually know 3 pieces of information. You see what I mean? You know the 8, the 10, and the 53. You know 3 pieces of information. Option number 1, you use the 8 and the 10 and do the Pythagorean theorem. Because when you know 2 sides, you can find a third. Or you can use that angle we just found, the 53, and either one of the other sides and use sine, cos, or tan. You have options. I'm going to do the Pythagorean theorem because we haven't done it yet, and maybe you need a little bit of a review. So I'm going to use the Pythagorean theorem to find that Vy side. Okay, so number 2, I'm finding that shared side that we're calling Vy. The Pythagorean theorem is a squared plus b squared equals c squared. What number do we put in the place of c in the Pythagorean theorem? C is always the hypotenuse. So it's going to be a squared plus 10 squared. So I plug the 8 and the 10 in, but the 10 has to be in the hypotenuse spot because it's the hypotenuse. And then we go a squared plus, well, that's actually 64 equals, well, that's actually 100. But now I have to get that a all by itself. So I'm going to remove that 64, minus it to both sides. So on the left side, I have a squared all by itself because those canceled out. And on the right side, I have 100 minus 64, which is 36. You square root each side and you get that a equals 6. So we just found in this missing, or in this triangle up here. Okay, erase this. Oops. In this triangle right here, this side is 6. So we just found the shared side. And now, finally, we can use the 17 and the 6 in that left triangle to find angle number 1. So this is step number 3. we are finding the other half of that angle, which is the angle XYV. So just this slice here. So that's my eyeball then. If I'm looking for that angle, that's my eyeball. The 17 is the opposite side and the 6 is the adjacent side. So opposite adjacent is tan. So tan of that angle, which is XYV, that little number 1 angle there, is opposite 17 over adjacent 6. And it's tan, and you're looking for an angle. So that means you press shift. And we should get that it equals 71 degrees. Okay, we're not done. What do we do now? Yes, Emily? So ultimately, we were looking for angle XYZ, which was the big entire angle. So we have to go 53 plus 71, the 2 answers we got. And that whole angle then is 124. Yeah. You didn't get what? You didn't get 71? So you went 17 divided by 6, then shift tan. Still no? Okay, last one, you guys. Stay with me. We got 10 minutes to the bell. I hope this only takes us like 7 or 8. Okay, copy that down. Determine the size of angle XYZ. So once again, we're looking for an angle with 3 letters in it, XYZ. We're going to figure out what angle that is precisely. And here's my big diagram. So a very, 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 very important piece of information you need to know is that we can only use sine, cosine, tan in right triangles. The triangles that have a right angle. Okay, so where are our 2 right triangles then? Our right triangle number 1 is the big guy, because there's the right angle, right? That's triangle number 1, that big one. And then our second right triangle is that top one. You see what I mean? So this is our only right angle. So we have either the giant triangle or just the top half. So this right here isn't a right triangle. You see what I mean? There's no right angle in it. But look at what angle we're looking for. We're looking for angle XYZ. Whoops. We're going from X to Y to Z. So I'm looking for an angle in a triangle that's not even a right angle. Okay? So in that triangle that I've outlined there with the sparkly pen, which I'm obsessed with, I can't use sine, cos, or tan in that triangle because there's no right angle. So what we have to do, or does anybody see what we have to do? Yes, Emily. Okay, so you're way ahead of me and you're absolutely right. But does anyone know, like, how are we going to find this guy? Like, what do we ultimately need to find to be able to find that little sliver? Any takers? To be able to find that little sliver, we need to find this whole angle and then subtract off that section of it. If we can find that whole angle, and we know what that size is, if we remove this slice, well, what's left will be what I'm looking for. So I'm actually going to subtract angles here. So first, I'm able to find this angle right here. I'm able to find that guy because in that upper triangle that he's a part of, so this guy here, I know two things. I know the 15 and the 17. With two things, I can find whatever I want. So with 15 and 17, I'm going to find that angle there. Okay, so this is my eyeball. The two sides are hypotenuse and adjacent, that's cos. So cos of my angle y there is going to be adjacent, so 15 divided by 17, hypotenuse. When you go 15 divided by 17 and you go shift cos, okay, that's going to be 28 degrees. And I'm actually going to specify, sorry, this is the little angle y, so this is the angle TYX. So we just found that this guy right here, just that little sliver, is 28 degrees. So I know what that chunk is, okay? So if I can find this whole angle here now and just remove 28, I'll know what that other sliver is. Here's the problem. If I want to find that angle, that's the giant angle in the giant triangle, I need to know two things in that giant triangle. I only know the 15, okay? I need to either figure out the length of this side or the length of the other side. Now, Emily already touched on it. She saw that we could use the Pythagorean theorem with 15 and 17 to find this missing slice. If I can find this missing piece right here, I can just add it to the 6 and then I'll know the length of that whole big chunk. So I'm going to do the Pythagorean theorem with a squared plus b squared equals 17, sorry, c squared. I'm ahead of myself. Okay, so 15 squared plus b squared equals 17 squared. That's 225 plus b squared equals 289. I'm going to subtract 225 from both sides. B squared equals 64. I square root, b equals 8. I know I'm going fast. If you need to go back and watch this example again, start to finish, you'll have the video, okay? So I just found out that this is 8 centimeters. So the whole side is 14. So in that big giant triangle, I know one whole side's 15 and the other whole side's 14. So I am now able to find this angle right here using the opposite side of 14 and the adjacent side of 15. So opposite's way across 14, adjacent's right beside. Opposite and adjacent is tan. So, whoops, tan of my angle. Oh, I'm in red still. Tan, and this is my big angle, so I'm going to call it TYZ. Tan of my big angle is opposite, so 14 over adjacent, so 15. You're going to press shift or second, 14 divided by 15 for tan is 43 degrees. So I know that this whole giant angle right here equals 43 degrees. Right here, this whole thing is 43 degrees. So if the whole thing's 43 and that slice is 28, you just go 43 minus 28 leaves you with 15 degrees. And that is what that sliver X, Y, Z is that we're looking for. Okay, that's our answer. Because 28 and 15 come together to make that 43. That's a pretty tricky one, and I get it. I acknowledge that. So if it helps, come back and watch this video a couple times. You only have 6 questions, like not 6 A, B, C, D, blah, 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 literally only 6 questions for homework, okay? It's page 118, number 3AC, 4AC, and 5AC. Okay, in each of those questions, there's also a B, obviously. It's A, B, C for each one. If you want extra practice, go ahead and do B as well. But I'm only requiring you to do 3, 4, 5, A, and C. That's perfect